Hi, everybody. Thanks for joining today. My name is Andrew Shikyar. I lead marketing here at FIDO Alliance. I'm very pleased to have two expert speakers today to cover one of the hottest and most pertinent topics related to FIDO authentication, which is how FIDO can help organizations achieve SCA compliance in accordance with the PSD2 directive. Thanks. As we approach the mid-September compliance deadline, the imperative for SCA compliance only grows, and it's little wonder then that we've seen such a strong interest in today's webinar. This is one of our strongest registrations we've ever had, and the turnout's fantastic, so it's very good to have everybody on. The speakers today are Alan Martin. He's the VP of Strategic Partnerships at Thales. He's also the co-chair of the FIDO Europe Working Group. We also have my colleague, Ray Hayward. Ray is FIDO's Certification Director. If we take a quick peek at the agenda, you'll see that Alan will first cover FIDO Essentials. This is important for those of you on today's webinar who might not be familiar with FIDO. And then he'll talk in more detail about the RTS requirements and FIDO's fit therein. We'll then turn things over to Ray. She will then cover the necessity for evaluation and how FIDO's certification program can be utilized for such purpose. Before we start, just a few housekeeping items. First, yes, this webinar will be recorded, and the slides and replay will be shared with you afterwards. Secondly, we've shared a white paper on our analysis of how FIDO complies with the PSD2 RTS requirements. You can find that in the GoToWebinar client on the right-hand side. It's also on our website, in the Discover section, the resource center that we have on our updated website. Third item, if you have any questions, feel free to ask them through the GoToWebinar client. So you'll see a little question box. You can type questions in there. I will answer them midstream if possible. Otherwise, we'll take them in a Q&A at the end. Q&A at the end, again, we'll work through the queue of questions and ask them to our panelists. Any questions not answered, we can address via follow-up email. Last but not least, at the end of the webinar, or when you log off, you'll see a survey. Please take a few moments to fill this out. Your feedback's really important to helping us shape our webinar program moving forward. So with that, I'm very pleased to introduce to you Alan Martin of Thales.
Thank you, Andrew. I need to have control, please. I need to have control. Okay, very good. Thank you. So, as Andrew said, we'll start going through some of the basics of FIDO for those of you who are not quite familiar with the FIDO Alliance and the FIDO standards. And so if you can move, because I cannot. So if you could move the slides forward, yes, thank you. So to say a few words about the FIDO Alliance itself. So the FIDO Alliance has been around since 2013. It is an industry association with a very narrow focus. We only work on authentication standards. We are actually quite a large membership. We have 240 companies in the Alliance. And it is actually the largest ecosystem for standard-based authentication. There are actually almost 600, we're close to 600 FIDO certified solutions today. This shows you digital identity at large, and you see that there's a lot of things around digital identity, starting with identity proofing, user management, and so on. And again, what FIDO does today is strictly authentication. The aim is very clearly to replace passwords with better means of authentication to fight phishing and all the problems that you know very well about passwords. So that's very clearly the focus. This shows you the board membership. There are 40 companies on the board of FIDO, and it is a very good representation of the diversity of companies that are working together. You find on the left-hand side companies that work in consumer electronics. So you find big names like OS providers like Google and Microsoft, chip vendors that build those chips in the computers like ARM and NXP and Qualcomm, phone vendors like Samsung, or PC vendors like Lenovo, and so on. In the middle, you see a lot of companies that focus on security and biometric. So you find Thaddeus, my company. You find IDEMIA, you find Knock Knock Labs, Dayon, OneSpan, and so on. So quite a large number of vendors that have FIDO certified solutions. And on the left-hand side, or the right-hand side, sorry, you find, most importantly, service providers. These are companies that are using FIDO and that are promoting FIDO. And you find there companies that represent the banking community, like Bank of America, like Visa, MasterCard, companies that are in social media, like Facebook or Line, in the healthcare sector, like Aetna, and so on. So quite a variety of representation, which really helps the FIDO standards to cover the needs of all these different markets. And talking about markets, if I can move forward. There we go, sorry. And so authentication, as you probably understand, is a very horizontal subject. And so you find the needs for authentication in many vertical markets: banks, e-commerce, as I just said, social media, enterprise security. And you see here illustrations of some of these companies that have deployed. For example, in enterprise security, Google made an announcement not so long ago, around about 4 months ago, that since they deployed FIDO to all their employees, they've seen absolutely no phishing attacks. They've completely protected themselves from phishing attacks through the deployment of FIDO to their employees. This shows you the different FIDO standards. Originally, the Universal Authentication Framework was the first standard that came out from FIDO. UAF is a truly multi-factor authentication standard, meaning that FIDO authenticators support different means of identifying people, for example, through biometrics or PIN codes, and the device on which this authenticator runs, it proves the possession factor. So they're truly multi-factor authentication solutions. U2F is a standard that was introduced to address the needs of those companies that still want to rely on login and password. And so there's still a password that is entered in the usual way. And U2F devices bring the possession factor. So the addition, very often in the form of USB keys that you would insert in your device, in your PC, to prove that that you have the proper possession factor. Interestingly, there is still a user action, even for U2F devices. You have to prove that you are there by touching the device. So this is important. FIDO protects, again, against scalable attacks like phishing and man-in-the-middle attacks. And the fact that the device doesn't work alone is helping in that sense. FIDO 2 is the most recent standard. And what is very interesting with FIDO 2 is that it brings support, standardized support, to web browsers and platforms, and more specifically Windows 10 and Android 7. What does that mean? It means that in browsers that are FIDO enabled, you have new APIs that have actually been standardized by the W3C. So this is a collaboration of FIDO with W3C to create what we call WebAuthn. So these are standard APIs that are now natively in all the major browsers you will see in a minute. CTAP is a protocol, a standardized protocol to connect these platforms to external devices. Okay, and that was specified by the FIDO Alliance. This shows you examples of FIDO authenticators and how you can find them today. We distinguish between what we call platform authenticators, those that are embedded within the device with which you interact, and roaming authenticators, which you carry and that you connect with the device with which you're interacting. So typically in platform authenticators, you will find smartphones with an embedded FIDO authenticator. But not only, you find PCs. There are now quite a few PC vendors that have what is called a Trusted Platform Module, or TPM, that embeds FIDO authenticator, meaning that your PC in itself is the authenticator. Roaming authenticators will typically be USB keys, smart cards, devices that you plug in or connect via Bluetooth or NFC. And we distinguish multi-factor authentication solutions from second factor only, as I already indicated. This shows you the principle of FIDO authentication. As I think you've understood now, with FIDO you need an authenticator. That's the device, it proves the possession factor actually. The authenticator holds a private key. The first step of FIDO authentication is the local user verification. That is the necessary step without which the second step cannot happen. The local user verification step consists of the user doing something with the device. For example, entering a PIN code, which will be verified locally by the device, or scanning a fingerprint, taking a selfie. So in other words, biometric data capture that is provided to the authenticator for local verification. In the case of second factor only devices, the user still has to do something, as I said. He has at least to touch the device. And so this local user verification step is a prerequisite for the second step, which happens online, where the authenticator talks to a remote FIDO server, and the FIDO server challenges this authenticator and expects a signed response back that it is able to verify. This signed response is calculated with the private key inside the authenticator. And the verification by the FIDO server is done with a public key. And so, as you understand, FIDO is based on public key cryptography, for those familiar with that term. So how do these keys get where they are? How does the private key get into the authenticator and the public key in the FIDO server? So this is very interesting, and actually one of the key aspects of FIDO, one of the benefits of using FIDO, and that is that you do not provision keys into FIDO. FIDO keys are generated within the authenticator itself. So the authenticators have the capability to generate a new key pair every time the user registers with a service provider. And so eventually, a FIDO device, a FIDO authenticator, can be used with multiple service providers. Every time the user registers with a new service provider, a new key pair is created in the device. Importantly, this registration step should happen after an initial step, which is the KYC step, the Know Your Customer. Knowing your customer is outside of the scope of FIDO, but it is something that as a service provider you have to do. So you, through whatever means that you have to identify your customer and subsequently go through the FIDO registration step. During this step, the biometric data or the PIN code, whatever identifies the user, has to be created and entered into the authenticator. Also importantly, authenticators communicate the public key back to the server in a secured way. And actually, the communication is of a certificate. In other words, authenticators communicate the public key inside a signed attestation, what we call a device attestation. The relying party has the ability to verify the attestation and actually verify the characteristics of the device. Authenticators with FIDO do not have to be deployed. Your users may already have an authenticator. For example, a smartphone or maybe a USB key that they bought on Amazon or wherever. So you do not have to deploy authenticators with FIDO. Your users may use an existing authenticator and register it with your server. Obviously, part of the device verification that you have to do as a service provider is to verify that this is a genuine device and that it corresponds to, for example, your security policy. And so this is quite possible with FIDO. I do not have time to go into the details of this. Let's move on now to what the RTS say, what are the requirements, and how FIDO actually complies. This is an overview. There's a lot of stuff on this slide. We're going to go through the details, so don't worry. But this shows you that FIDO maps very well, actually, with the requirements of PSD2. And you see here the mapping of the language, actually. I'd like to emphasize here just one thing. The challenge that is provided by the bank, as you saw before, results in a response, a signed response provided by the authenticator back to the bank. This is the authentication code as defined in the RTS. Let's look now at all of this in a little bit more detail. And by the way, as Andrew said, all this detail is in the white paper that is posted, that you can access actually through the webinar client. So looking at the authentication and the generation of this authentication code, all this should be based on multi-factor authentication, and as you probably very well know, a combination of at least two of these factors, and you see them listed here: inherence or knowledge or possession factor. With FIDO, the possession factor is the authenticator. I think that's been made very clear. What is interesting with the inherence factor is that FIDO supports any biometric modality. It depends actually on what the vendor provides. And a change or a mix of different modalities has zero impact on your FIDO server. And so that as a bank, you could deploy initial authenticators with fingerprint and later, or maybe at the same time, deploy authenticators that support facial recognition and maybe vocal recognition later on. And all this needs no change to your server. It is specific to the authenticator. And that is linked to the fact that biometric data is matched locally. From a GDPR perspective, it's also interesting to note that biometric data is matched locally and never leaves the device, which will greatly help with GDPR compliance, because biometric data is actually considered as sensitive data under GDPR. And if you don't do things properly, you get into all the complexity of assessments and so on and so forth. In the case of knowledge factor, some authenticators will support a PIN that is verified locally, and so FIDO is perfectly capable of managing the knowledge factor. Here again, the PIN is verified locally and never leaves the device. And as for the possession factor, that is the authenticator with its private key, obviously. And as I explained just before, this device will be able to generate the authentication code required by the RTS. As you also know from the RTS, there is this important notion of dynamic linking for remote payments. FIDO is perfectly capable of supporting dynamic linking. As a matter of fact, all FIDO authenticators can digitally sign transaction data. It is quite possible for the bank to provide to the authenticator the challenge plus a transaction text which contains the amount and the payee. In return, the authenticator will generate a signed response, which is the authentication code with dynamic linking. Now we can go a step beyond, which is actually a part of the RTS, which is the ability to display information on the transaction to the user and get the authenticator to sign what is displayed. This is not available in all FIDO authenticators. A USB key does not have a display, and so would not be able to do transaction confirmation, but a smartphone typically would. And so this capability of FIDO to to actually to perform what you see is what you sign is perfectly in compliance with the dynamic linking spirit of the RTS. An important aspect of the RTS are the confidentiality and integrity of the security credentials. Okay? And as probably you understand now, the private keys, which are security credentials in the FIDO world, are very well protected. FIDO protects the private key, it protects the PIN code or biometric data within a secure environment. And there are actually various ways of doing that. FIDO can accommodate multiple ways of deploying. The first is to embed the FIDO Authenticator in the application itself, for example, in a mobile banking application. There are implementations of FIDO Authenticators in pure software. Now, obviously, pure software is potentially vulnerable, and so vendors of the FIDO community implement FIDO authenticators in hardened software, if you will. So they implement security techniques like code obfuscation or white box cryptography, but it is quite possible to find FIDO authenticators in the form of SDKs so that they can be implemented in applications. You find FIDO authenticators in what we call restricted operating environments. I gave previously the example of the TPM in a PC, but most frequently you will find that in trusted execution environments in mobile phones. So a lot of mobile phones nowadays have TEEs within them, and FIDO authenticators can be built within the TEE of the phone. And finally, you find applications, implementations of FIDO authenticators in secure elements, in secure devices, which is typically the case of smart cards or security USB keys. The RTS pay a lot of attention to the life cycle of security credentials, and so there are a number of articles that discuss creation, delivery, renewal, destruction, and so on. Actually, with FIDO, you get the benefit of simplification for all of this, because with FIDO, you don't create, through key ceremonies with key custodians and so on and so forth. Some of you may be familiar with this. You don't create keys and then provision them in devices. You do not do that with FIDO. FIDO, the keys are created inside the device, and you upload a public key, which is far less sensitive. And so, from a creation and delivery perspective, FIDO is very well suitable to meet the requirements of the RTS. With FIDO, private keys, key pairs, do not expire. So the key that's in the device will be workable for as long as you wish. There is no expiration defined by the authenticator or by the FIDO standards themselves. On the server side, you may very well mark a public key as suspended, and then you resume or revoked or you destroy. So you have a lot of freedom to manage your keys through your service, which again makes it very simple from a deployment perspective. Now, of course, you may want to manage private keys within the devices themselves, but that is outside of the scope of FIDO. You would have to have some form of management, of remote management of your devices, but it is not mandatory. You can do everything from the server side. So all this is very nice, lots of security and nice stuff in FIDO, but how do you ensure that all of this corresponds and meets the FIDO standards and the requirements of the RTS? And so you need evaluation. As a matter of fact, the RTS say, it's a mandate, you have to do evaluation. The mandate is of Article 3.1 is listed here. The security measures that you as a bank put in place, they must be documented, they must be periodically tested, evaluated by independent auditors. Okay. And today, so card schemes are putting this in place for accessing the account for account aggregation purposes or to trigger an instant payment. The national competent authorities have defined nothing at all. It doesn't exist. Okay. And so the good news is that FIDO has a certification program, and here actually hand over now to Ray that can help you greatly establish all of this. So, Ray.
Thank you very much, Alan. Appreciate that. So building on what has been previously stated, as well as how the FIDO certification program is necessary in meeting the requirements that have been established by the regulators through RTS. First, oops. Just a little bit of overview of the FIDO certification program. So it is a very well documented program that covers both functional compliance testing for authenticators, servers, as well as clients and SDKs. What the functional program covers is conformance testing, that it conforms to the specifications, as well as interoperability within the ecosystem that is deployed. In addition to the functional certification program, we have our authenticator certification program that deals specifically with the authenticators. Currently, it defines a security level that needs to be achieved when going through authenticator certification. So it tests the security measures of those keys, the protection of the keys and the biometrics on the device, and it is done by independent labs. Exploring this program a little further, we can see that we have 3 levels within the security program, and within each level is the base level and then a plus of that level itself. So building from the bottom up, we have level 1, which is any device, hardware, or software. And then we have level 2 that builds on level 1, where we're looking at implementations of a hardened software. When we look at level 2, the requirements get into forcing the vendors to implement what we call an allowed restricted operating environment. And as previously mentioned, this is in the form of a TEE or secured element. At level 3 plus, or 3 and 3 plus, you're adding additional security assurances, and most likely the types of examples of devices that you see at this level do implement a secure element. We're going to take you through the different programs. This is just a breakdown of kind of the base requirements, some examples, and the certification process required. At level 1 is base FIDO specifications implementation. So whether it's UAF, U2F, or FIDO2. We're looking at better than password, which is one of our primary goals from a usability perspective within the ecosystem, where FIDO is unphishable and the biometrics are more convenient within the device itself. The keys and biometric templates are protected, similar to how other password protection mechanisms that are out there, like password manager applications and things like that. Requires the best facilities offered by our hosting operating systems. So this is base level 1. Level 2 adds additional security assurances with regard to what we call white box cryptography or different obfuscation techniques to defend against compromise of the hosting operating system. Examples at this level 1 are Androids or iOS applications, platform built-in authenticators, and then also we recognize with the newness of the program that a lot of vendors are opting to go with level 1, although they actually are able to achieve our higher levels, level 2, 3, or 3 plus. So those that have been initially certified at level 1 can achieve our higher levels. The process for level 1 is very simple and basic. The vendor at both 1 and 2, level 1 and 1 plus, create what we call a detailed design document. So it's basic definition and documentation review. Although at level 1 plus, we do get into where the lab is required to do additional penetration testing. There is no lab for base level 1. It's all FIDO internal. We do have what we call our security secretariat, and there are certain aspects of the authenticator that are reviewed at the interoperability events, and then also a vendor questionnaire is completed, submitted to the Security Secretariat, and information is validated internally with FIDO. The next is level 2. Level 2 builds on level 1. And as I mentioned before, this is where we introduce the requirement of the use of a restricted operating environment. We have a document that's called the Allowed Restricted Operating Environment document. It's one of the 4 program documents, and it identifies which restricted operating environments are able to be certified for our program. There is a separate USB, BLE, and NFC restricted operating environment. These are also considered. All 3 transports are supported within this program. And at level 2, we start looking at defenses against larger scale attacks. In addition, for level 2+ is where we start getting into what I will describe a little later, requirements for a companion program. And I'll describe that in a few slides. Some examples for level 2 and 2+ are Android apps that are using the TEE within the smartphone, the PC TPM-based implementations, security keys that support the transports, and then also, as mentioned before, level 3 capable authenticators that haven't applied for or achieved level 3 at this point in time. So from a certification process, when looking at the vendor, level 2 is requires, first I want to start with the lab. So level 2 and 2+ both require a lab, but the testing is slightly different between these 2. Level 2 requires just a documentation and definition review, where level 2+ adds additional type of testing, where you're looking at different penetration testing, you're doing attack potential calculations. So it's a little bit more extensive, but we would expect that since it adds additional security. From the vendors' requirements, they would create a detailed design document that will be submitted to the lab. And on level 2+ is where we start seeing our source code being required as a submission process for authenticator certification. Here, FIDO is just an administrator. We do actually receive a report from the lab at these levels that is an evaluation report, and it is signed off on by our Security Secretariat. Lastly, we have our level 3 and 3+. So level 3 is in addition to level 2. At this level, we start looking at the different types of physical attacks that can occur on our devices. And these defenses protect against disassembling, probing, glitching, and other such physical type of attacks. Level 3+ also gets into defenses against chip level, such as decapping and probing. Some authenticator examples are USB, BLE, and NFC security keys or smart cards that are using secure elements or other hardware defending mechanisms. Some phones and platform authenticators may be able to achieve level 3, but it's slightly uncommon. The certification process here is very similar to level 2 and 2+, where the lab is required to do all the design review. So we have verification, validation of penetration testing, we do attack potential calculations, and test plans are required to be provided, and a sample of tests are executed on the device itself. The vendor must create detailed design documentation and supply source code. There are additional requirements at this level with regard to the companion program, which I will mention on the next slide. But also FIDO is strictly an administrator. It's the lab that is accredited that actually runs the tests, and we just validate the results. The companion program is something that FIDO implemented as a way to reuse as much as possible from other industry well-known certification products or processes. The primary reason for using this was to reduce time, effort, and cost for both the vendor as well as FIDO from an administrative perspective. So the companion program is detailed out in what we call our mapping document. So we mapped all of the FIDO requirements to the requirements of the companion program, and all that the lab does is validate that the companion program, the device is certified for that companion program, and he does the evaluation on the delta requirements of FIDO that are not covered in the companion program. Currently, we have one companion program available, and that's for level 3 and 3+, and this is common criteria, and it goes up to AVAVAN level 4. We are in the works of developing a level 2+ and 3 utilizing FITS 140-2. And then lastly, the level 2+ that is not yet available is the GP or the Global Platform TEE Protection Profile. So stay tuned for those to be implemented shortly. Recently, towards the middle to the end of last year, we announced what we called our biometric subcomponent certification. This is an independent certification from the functional and the authenticator certification programs, but it does tie into the authenticator certification, and I'll explain that on the next slide when we go through the process. Here, all the lab does is perform the testing for our false accept and our false reject rates. And it tests for all operating points for false accept and false reject. The testing requires 245 subjects, and for the biometric subsystem to achieve the FAR, it must be 1 in 10,000 at an 80% confidence level for a 3% FRR. So that's why you see the FRR must be below 3 in 100 at an 80% confidence level. We also include what we call baseline presentation attack detection, or PAD. The testing is done with at least 10 subjects, so that's the minimum required. Both of them are minimum requires. We test the requirements for PAD have defined 3 levels, levels A, B, and C type artifacts. Currently, the program as implemented in the initial stages is that we are looking at just testing at level A and B. With the 10 subjects, you need at least 6 level A and 4 level B. And of those, we look at 5 level A have to be less than 20% and all less than 50. 3 level B have to be less than 20% of the imposter attack presentation match rate, and all less than 50. So those are the requirements. We also introduced a portion of the testing where biometric vendors can come in and opt for what we call self-attestation. So they can self-attest at a FAR at 3% or less than 1 in 10,000, say 1 in 50 or 1 in 100,000. What the lab is required to do is receive all the documentation of the test data and reports from that vendor and validate the results based upon the requirements that we have defined. So that's the biometric subcomponent certification. So the complete process, since I did say the biometric subcomponent is independent, it's independent for level 1 and level 2. For vendors, authenticator vendors, seeking level 2+, 3, and 3+, will be required to utilize, I don't know why we're advancing. Can we please go back? Thank you. Will be required to utilize a biometric, FIDO certified biometric subcomponent. Okay. So the basic process is that the biometric vendor selects, applies for biometric certification, contracts with an accredited lab. The lab executes the testing, FIDO reviews the report, and then we have a biometric subcomponent that's certified for FIDO. This product also requires what we call an allowed integration document, and that defines the changes, the variable changes that are allowed between the software and the hardware to be integrated into the final authenticator product. So as you can see here, the arrow comes down to where the vendor, the authenticator vendor, chooses to implement a FIDO certified biometric, goes to, depending on the level that they've selected, goes to an accredited lab. The lab completes all of its testing, makes a decision, submits a final report to FIDO. FIDO signs off on it, and we end up with what we call our FIDO certified product. So this is the final stage. Now remember, I want to be very specific here that the biometric subcomponent is an independent program than the authenticator certification until we get to the requirements for level 2+, 3, and 3+, which requires a FIDO biometric certified subcomponent. Okay. So when we start looking at the requirements, the documentation, of the program itself, we get into what we call our accredited labs. We have several accredited labs. They go through a very rigorous program of training and testing in order to achieve this, the significance of being an accredited lab. So all our products for biometrics go through our biometric accredited labs for evaluation, and then all our level 2 and higher, including 1+, once it's developed and implemented, will also go through labs that have been accredited to test the requirements and complete the evaluations based upon the FIDO specified documentation. All right, so this is where we get into our third party verification and validation. So this is the last aspect of the FIDO certification program, and it's the importance of metadata. So many of you might already understand or know what metadata is, but metadata describes the authenticator characteristics, describes the characteristics of that authenticator. We have a metadata requirements document that is part of both the authenticator certification and the biometric certification programs. And these the products are required to contain specific fields for their characterization, and that information is validated by the lab. Even at level 1, we validate metadata. Now this is the primary benefit of this is that FIDO offers what we call our metadata service, and that's kind of indicated down here on the graphic. And authenticators or products that have gone through FIDO certification at the authenticator and biometric level are allowed to submit their metadata into the metadata service. And this creates an element of trust for relying parties that are utilizing FIDO authenticated or FIDO certified products, because we have verified and validated that metadata to be accurate. So it enables that trust mechanisms that relying parties can go identify authenticators that they want to use and implement, and the down trickle event is that the users are also utilizing authenticators that have been validated and certified through the FIDO program. Okay, so I'd like to pass it back to Alan to finish with the takeaways. Alan?
Yeah, there we go. Sorry, I was muted and I could not unmute myself. Apologies for that. So we've almost run out of time. So quickly, takeaways. So what you hopefully have got from this webinar is that as a bank, as an SPSP, in the context of PSD2, you need to make sure that your solutions comply to the RTS. This is actually part of the RTS. It's part of the law. You have to do that. And as a matter of fact, you have to ensure that whatever you implement in terms of security has to be tested by independent auditors. FIDO can help. Obviously, will be up to the national competent authorities to decide what is a compliant solution and what is not. What we mean when we say FIDO can help is that we have standards, the standards conform, and we have proof that any implementation of FIDO complies. We do that through the certification program. We ensure that compliance is from a functional perspective, interoperability is achieved, and from a security that we achieve the levels that have just been described by Ray in the program. So with that concludes the webinar, and we can move to the Q&A if you have questions now to answer.
Yeah, thank you, Alan. This is Andrew again. So several of you have asked questions in the chat box. Please send more in. We have around 10-15 minutes to go through these. And then again, anything that's not answered, we'll try to get back to you by email. You can also always send an email to info@fidoalliance.org, and we'll answer you there as well. And another reminder, these slides will be sent to everyone. They'll be posted. The link will be sent to you following the webinar. So if you have questions about specific slides, please be patient. They'll show up in your inbox. So a couple questions off the bat. Alan, maybe you could help here. Does FIDO2 support transaction signing? So for example, confirmation of a money transfer.
So yes, it is described in the standards. It's a very good question because it is described in the standards as an extension. And so yes, the extensions for transaction confirmation, for transaction signing is provided for in the standards. Now, is it implemented? That's the question. And so here, as I understand from the present releases in the different browsers that I mentioned, the extensions are not yet supported. So it's a matter of time. The extensions should be supported, in the coming months. It's a must-have for PSD2. In the case of UAF, it is fully inclusive in the UAF standard.
Okay. Another question for you, Alan. So questions around biometrics. So do on-device biometrics such as Touch ID, Face ID, and I'd say Android fingerprint as well, do those constitute strong authentication under PSD2? What are FIDO's views therein?
So that is another good question. If as a bank you implement Face ID or Touch ID or its equivalent in Android in your mobile banking application, are you compliant? It depends what you do afterwards. With the biometric verification, you verify one factor, that is the inherence factor. And so you're missing another factor, for example, the possession factor. And so you have to prove that your user has the proper device. And to do this correctly, this proof should not be reproducible. And so therefore, it requires cryptography, requires unpredictability. And that's what FIDO's challenge response mechanism provides for. So yes, you can implement Face ID, Touch ID, but it is not sufficient. You need to prove the possession factor in a secure way. FIDO helps with that.
Okay. So Ray, a couple of certification questions for you. What should a vendor do to reach level 2 certification in iOS? So should the key pair generated in secure enclave be documented? Are there any other recommendations that you would have?
So level 2 is where the allowed restricted operating environment document, or as we refer to as the AROE. This defines the list of restricted operating environments that are allowed at this level. So it has to meet, first and foremost, this requirement. So when a vendor is applying for level 2 or higher, one of the first things that we do on our side is gate check that to make sure that the base documentation, which is provided within the vendor questionnaire, provides that information and that it is on the list. All right, so that's one of the first things that the lab is going to check to make sure. So all the program documents are available on the FIDO website under the certified product tab. I think it's under the Authenticator certification. So if you go to just that base page, you'll be able to see all the required documentation for the program, including that list. So as long as it's on that list, it will be allowed to achieve level 2. Now, level 2, as I also mentioned, is all verification and documentation. So the vendor will need to not only complete the vendor questionnaire for all level 2 questions, they will also need to submit the documentation to support their rationale in their vendor questionnaire response.
Okay, thank you. All right, another question, which is probably also covered in documentation, but let's clarify this. How much penetration testing is required for each level? Is this something we can quantify? Is this something we specify?
So we don't actually specify. The requirements are defined within the security requirements document, and a lot of this is based on the companion program that is utilized. So level 3 and 3+, which is the program that's available at the higher levels that do require a companion program. The penetration testing is defined within the requirements of the common criteria. And the lab is required to submit a sampling of tests that will be, or the vendors is required to submit a sampling of tests that the lab will execute on. In addition to that, we require the vulnerability assessment to be completed, and based on the vulnerability number that's identified, it requires additional testing in that regard. So you're looking at AVAVAN level 3, AVAVAN 4. So the moderate type numbers, I think it's like 23. Don't quote me on this. I don't have this all memorized. But those are the types of tests that the lab will do in addition to what the vendor has supplied to the lab to execute. So there isn't a number like 4 or 5 or 10.
Okay. So Alan, coming back to you. So from which level of certification do you consider compliant with RTS PSD2? Is it starting from level 2 or 2+, or can we make that sort of, can we distinguish based on level?
So that's a very good question as well. The RTS do not specify that. Now, if you look at card schemes, some card schemes are coming up with certification programs and their own security level. And so maybe level 2, 2+, whatever, then we have to check whether what is requested by the card scheme can be achieved by one of the security levels of FIDO. I'm pretty sure that at L3+ you cover everything. Okay, so the question is more for the lower levels of certification. Now, if you're not looking at card schemes, but access to the account, so you're an account aggregator, you're a bank, you're providing access to your accounts for an account aggregator, for example, how do you ensure that your authentication solution meets the requirements? Well, the NCAs, the National Competent Authorities, haven't defined anything. It is not defined. Does level 1 meet the requirements? Maybe, maybe. Is FIDO level 1 better than SMS OTPs? Probably. And SMS OTPs are a recognized authentication method under PSD2. So to answer your question, if it is an authentication solution to protect access to the account, I'm pretty sure that FIDO level 1 meets the requirements. If it is authentication for a card scheme, that will be card scheme dependent. It will depend on whatever they've defined in terms of requirements. And the analysis of the correspondence between those requirements and the FIDO security levels needs to be done.
Okay. Now, another topic we talked about in the presentation, but as far as transaction approval, the question is, how important is it to have display capabilities and authenticators to do transaction approval?
How difficult is it? Is that the question?
How important is it? So
how important is it?
How would one do it without a display?
Well, this is again a part of the fuzzy area where national competent authorities have to define more precisely. For example, you receive an SMS that conveys the transaction details and an OTP. Is that compliant with the RTS? Well, the answers have been yes. So in respect of that, one could assume, because obviously this is not a very highly secure way of doing things, you could, you know, in light of that, a FIDO-based authentication solution could consist of a PC displaying the transaction details and a USB key inserted in that PC. Why not? As long as the USB key signs the transaction details. It is obviously better to do that on a mobile phone and ensure through the authenticator, you know, and the vendor solution, if you will, that whatever is displayed on the screen of the PC is what is going to be signed by the authenticator. That is definitely the better method, yes. But at this stage, the national competent authorities have not defined anything.
Okay. Ray, a question for you. If one uses a FIDO certified SDK from a vendor, do the apps that use it have to get certification separately? So I want to have a certified app from a SDK to have, you know, maybe talk a little bit about derivative certification and how that would work in this instance.
Yeah, so we do have a program that allows for derivative certifications, which with the launch of the Authenticator Certification Program, it used to be, because we didn't have any security levels, but now that we have security levels, a little bit easier to arrive at whether or not you can achieve derivative certification. And that's reusing a certified product where you do not make any changes to the FIDO implementation. So as long as there have been no changes with the defined aspect, or what I would, maybe a term that's commonly used is the target of evaluation, which is what's being evaluated, what's inside, or what's defined to be the FIDO product, has no changes, then a vendor can apply for what we call our derivative certification. Now, if there are changes to that device, we need to examine those changes, and what we use is our FIDO impact analysis report. And we'll make a determination as to whether or not those changes allow a derivative, or if they're minor, then it would encompass what we call a delta certification. And if it's a major, then there's the requirement of going through recertification. So it really depends on how that product is what I would call reused by that vendor who's trying to either get a derivative or potentially seeking a delta or new certification. And that's all defined within the policy documents for the Authenticator Certification Program.
Okay. Great. One last question for you. For a fully compliant mobile solution, does it mean that every biometric must have completed the biometric component approval? So I think this question means if I'm L3 certified, is every modality, you know, which requires biometric testing, is every modality tested in that instance?
So for level 3, so you can just be certified with a specified modality, okay? At the higher levels, that's where the complexity comes in. So if you do support multiple modalities, that biometric certified component needs to be certified through all the modalities.
Okay.
But So like at level 1, if a vendor, or just as an independent program, if a biometric subcomponent chooses to certify their product and it supports multiple, they can be FIDO certified in one, such as versus face or fingerprint. They can be certified biometric fingerprint.
Okay, very good. Well, listen, this brings us to the end of our hour, so we're over time. And so anyone whose questions did not get answered, we do have them in the queue, and we'll come back to you. Or you can email us at info@fidoalliance.org, and that way we'll also be able to answer your question. Again, the webinar recording and slides will be emailed to you and posted on our website. And then please do take a moment at the end of this to fill out the survey before you log off. So I'd like to thank both Ray and Alan again, and thank all of you for your time today. We'll look forward to seeing you on a future FIDO webinar. Thank you.